are team number 2. We are Gaby, Lucy, and Karen. The problem that we have to do was the number 2 that says calculate the area between f of x is equal to x squared, 1 minus x squared. The x-axis and the vertical lines, x is equal to minus 0.5 and x is equal to 0.5. The steps that we have to do to solve the area problem was A. Graph the function using a graphing tool and shade the region.
Because of the form of our function, we decided to integrate respect to the x-axis. As we know, our function is f of x is equal to x squared, the root square of 1 minus x squared. So we're going to integrate this with the method of trigonometric substitution. So, first we had to substitute the variables in a function and then integrate it with the method that we already designed. We know that we have a triangle, and with that triangle, knowing that we have the root square of 1 minus x to the square, we know that that is supposed to be sine because that's opposite over hypotenuse. So sine of theta is equal to x over a, sine of theta is equal to x over 1, and you know that sine of theta is equal to x, and x is equal to sine of theta. Now, if you derive it again, you're going to get d of x, which is cosine of theta, times d of theta. Now, getting the root square, it's just simply solving it, and then you have the root square of 1 minus x squared is equal to 1 minus sine square of theta. Then you have 1 minus x squared is equal to cosine square of theta. And finally, the root square of 1 minus x squared is equal to cosine of theta. This is our data. Now that we have found the answer to our root square, it's just a matter of substituting on the integral that goes from 0 to 0.5. And it's simply going to give you sine square of theta times cosine square of theta times d theta. So we already know d theta and we can substitute, and with that it's just simply a matter of using the third rule of sine and cosine trigonometric substitution. And finally, it's just getting to the answer after solving all of this, which is equal to 1/8 of theta minus sine to the 4 theta over 32 with an interval that goes from 0 to 0.5. At this moment, we already know or have the result of the integration, but it is important to change the two trigonometric values, the theta that is equal to arc sine of x and the sine of 4 theta. But for these, we use the formulas of double angles and the sum of angles. We transform the term to only a pure simple sine and cosine of angles. So finally, we got to our final answer, which is arc sine of x minus x times the square root of 1 minus x squared times 1 minus 2x squared all over 8 with a little thingy right there that goes from 0 to 0.5.
So, knowing this, we just have to substitute the last function with the information that we have. But, as we know, the variable a is equal to 0. Therefore, the f times a can be directly eliminated. So, we just have to evaluate the integral with the variable b that is equal to 0.5. So, we substitute the x in the function for that value. We already have the final result of one region, but as we know, the problem asks us for two symmetric regions, so the final step is to multiply the result for 2, and that's our final answer. And finally, we graph the function. In the graph, we can observe the function but also the two limits, which allow us to identify and shade the region that we have to find. It's important to mention that here we have two regions, but as they are symmetric, we can use just one to solve the problem.